Okay, let's get started. What do I do? Alright, hello.c. So it wants me to check if I do have compiler. So that's something new about low-level code. I've forgotten this. You need a compiler. It looks like we have something. Clang 21. We have Clang. Let's start with. In fact, I want to make it. Where's the output styles? Okay, so you have to open it in terminal. Then we refresh, I guess. Refresh extensions. Okay, so I think it doesn't know that that I want to write the project, because it says, do you want me to do it for you? Which is exactly not what I want, so we do not write code. This is a learning repo. The user wants to write code. You will be a helper and a teacher. Alright. So I'll say we have Clang. Let's create the first project. I will code, thank you. Let me save a quick note about you. You dastardly Claude, what are you doing? What are you writing? What are you writing? Wants to write all the code. I'll roll as teacher helper, not coder. Thank you. Why are you writing stuff, dude? Project 1 concepts. What's different from web dev? In C, main is the entry point. There's no runtime, no event loop. Okay. The OS calls main directly. argc, argument count, and argv, argument vector, are how CLI args arrive. Similar to process argv in Node, but is a raw array of C strings, which are character pointers. Okay, I'm not sure exactly what pointers are. I mean, I guess I know the concept of they point to something, they're not something themselves, but okay. We might drill into that later. Printf uses format specifiers like %string and %d integer, no template literals here. Alright, so template literals, I guess, is an abstraction that I'm very used to as a TypeScript developer. Now let me create the file with a scaffold to fill you in. Don't even create files. I will create files. Okay. I don't think it gets that it's not meant to do stuff. I'm meant to do stuff. That's the plan. Fully hands-on. Alright. Here's what to do. Create hello.c. Alright. Hello.c. It's good to know that VSCode has a little C. It recognizes it. That's cool. Alright, so we want to write a program that prints hello world, prints how many CLI arguments were passed, loops through each argument and prints it, skipping the first one. That's the program name. Okay. What you'll need includes stdio. Alright, so what I'm going to do is Ask it, explain this line. Is it importing some sort of package? And I guess my learning process with it is just to interrogate it until I understand stuff. I'm not going to understand stuff perfectly, but I want to know the answers to some of these questions that I have. So include stdio.h is a preprocessor directive. Before your code even compiles, the preprocessor literally copies the contents of this into your file. Okay, so it's not really an import of a module or something like that. It's actually copy-pasting the entire thing. Okay, it's a header file that ships with your C compiler. It declares functions like printf, scanf, putS. Think of it as the type definitions, like, okay, that tells the compiler these functions exist and here are their signatures. Okay, it's a type definition, so it's not the actual functions themselves. The angle brackets mean look in the system, include directories, standard library. You can also use quotes for your own local header files. H is a header file, it contains declarations, not implementations. Okay, so this is a header file. It doesn't contain the actual implementation of printf, scanf, but it's like a metadata file that says they exist. The actual compiled code for printf lives in the C standard library, libc, which gets linked automatically when you compile. Okay, if it only contains the signatures and libc is already linked automatically, why do I need to include it? Great question. Alright, thanks, Claude. Good to know that your sycophancy is still around. This reveals how C's compilations works differently from WebDev. Okay. Hopefully you can hear my baby screaming in the background. He's cute. C compiles in two separate stages and each needs different info. Compile translates your C file to machine code. Okay, it compiles. The compiler needs to know printf signature, what args it takes, what it returns, to check your code is correct. Without it, the compiler sees printf and says, I have no idea what this function is. Okay, yeah, so I guess that's to be expected with low level. Is there's a lot of stuff that we just, as a high level developer, I just assume is there, but that's all abstraction. So this is at low level. It's if you don't give it the header file, if it doesn't have the signature of the function, it actually just doesn't know what the function is. Even though the library, the compiled code, gets linked. What is link anyway? Link stitches your compiled code together with libc. Okay. So the header satisfies the compiler, the library satisfies the linker. Okay, there are two different steps that need two different things. So compile. Okay, let's reword this so I can understand. Compile translates it to machine code. Is that ones and zeros, or does machine code mean assembly language here? I'm not sure. I don't care right now. So because it translates it into an even lower level language, machine code, it actually needs the signature to do so. That's okay. And then the link links the library, the built-in library, with my code, this, which currently is nothing. Okay. In TypeScript terms, imagine if TSC type checked your code using blah, but a completely separate tool wired up the actual implementations at the end. That's basically what C does, except it was designed this way in the 1970s, long before anyone thought to unify the two. Okay. If you omit the include, Modern GCC/Clang will give you a warning like implicit declaration of function printf. It might still compile, but you're flying blind without type safety. Alright. So, include stdio.h. And I'm curious, what does this stand for? What does that mean? Standard input output. Fantastic. Alright, that's the header file. Alright. Cool. Just trying to find the next step. It prints hello world. Okay, so this gives you printf. Int main. Alright. I save this. Alright, I've done the first line. Explain what's next. I have 0 context with C. Next is the main function. Every C program needs a function called main. It's the entry point. Okay. I have done a little bit of Go before, and that's kind of the same thing, right? So when you run hello, the OS calls main directly. Cool. Here's the signature. You'll write int. What is int? Why is there an int before my main? Silly. Int before main is the return type. Oh, the return type is before the declaration of the function. Interesting. Main returns an integer to the operating system. 0 means success. Anything else means error. This is what $? gives you in the shell after a command runs. Same as process exit code. Okay, cool. Main is the function name, not negotiable. OS looks for exactly this name. Alright, so I get that part, so I'm going to type that in. Int main. And then there's this, I'm guessing this is the argument stuff, right? Int argc, argument count. How many command line args were passed into the program name itself? Okay, so argc is an integer, and it's giving me how many arguments were passed when calling main. Alright. So hello Alice Bob gives argc equals 3. That includes the program name itself. Okay, it's good to know. Character, char, star argv. What is this? What is a star? Argument vector, an array of strings. Don't worry about the pointer syntax yet. Just think of it as a string for now. argv0 is hello, argv1 is Alice. Okay, so yeah, argv. So argc is the count, and then you have characters. Argv. The vectors represent the actual value. So I don't know why it's called a vector, but it's the actual value of whatever was passed in, right? And there's a pointer there. Don't worry about the pointer syntax yet. Normally I'd be telling it, don't tell me not to worry about it, but I am processing a lot of information for the first time right now, so okay, we'll leave that. I just don't know what this pointer is. Maybe I'll create a new file of notes.mp. Skipped. What is star pointer? And maybe I'll fill out notes after I get this program to run. Maybe that's the end of each video, is I figure out what I've learned during the session and put it up. Okay, so we've got a main function that returns an integer. We've got an argument count, which is an integer, and an argument vectors, which a pointer to argument vectors, which is characters. Alright. Sorry, and it's array, isn't it? It's an array. Obviously, because there's more than one. Alright, so now it says your code here. That's a comment, I'm guessing. Blah. And return 0, which tells 0 is success, I guess. So go ahead and add the main function and fill blank later. Okay, that's done. I believe we've written our first function, our first program, right? Now replace blah with 3 things. Printf, hello world, new line. Okay, no, I know that. So printf, hello world, please subscribe. And that, I guess, automatically escapes the end, so that's a new line. Okay. Cool. Print the argument count. Use %d as a placeholder for an integer. Okay, so second line, printf. You passed %, which I guess is the placeholder syntax, right? And d is, what is d, an integer? Why is d an integer? Arguments. New line. Yeah, and then we're printing argc minus 1, and that is because argc, we learned earlier, contains the name of the program. Okay, that's the program name, a real argument. Yep. Loop through and print each argument. A for loop. Now there's no, I'm guessing there's no map. We can't call a map on this argv. That's sad. I like maps. But anyway, let's write a loop for int 1, int I. Okay. So I is an int. This is very familiar to me in TypeScript, JavaScript. It's like const I, right? But I guess you're declaring the I by itself and then telling it that it's an integer. Equals 1. As long as I is less than argc, then you increment I understand this. We will printf arg, let's say argument, so it makes it's more readable. Argument, and then d being an integer again, and then the placeholder for a string, placeholder string, new line. So the argument number, a string and a new line, and then I being the counter index, and argv, this is the actual value of each arg. So we've got an argument. So what do we put in here? That's the placeholder for a string. Oh, yeah. Okay, cool. So we've declared 2 placeholders here. The first placeholder is the I. The second placeholder is the actual string. Okay, that's what's actually happening. This corresponds to this, and this corresponds to this. Which it didn't really tell me, but yeah. Start at I equals 1 there to skip the program name. Alright. That's written. So I'm gonna assume that you can run this just be using hello. Nope. Okay, one thing to fix before compiling. Every statement in C needs a semicolon at the end. Oh. Oh, wow. Your printf, boom, don't have semicolons. We need to set up prettier for this. I need to set up a formatter here. Okay. Yes, I am used to JS semicolons being optional, and see they're mandatory. The compiler will error without them. Amazing. Alright, then compile and run this. What the heck is this? Claude, tell me. So GCC is a compiler. So you're telling GCC, the compiler, hi compiler. Wall, enable all common warnings, uninitialized variables. I'm guessing it's not wall and wextra, but it's all and extra. Okay, so W, probably for warnings. Warnings all, warnings extra. Okay, and that'll apply to the compiled code. Okay, -O, output, the compiled binary. Oh, okay. So earlier, like, I just tried running the file. I tried running hello, but obviously I hadn't compiled it yet because this is low level. Sick. So it's going to output a hello. And then hello C. Okay, so it's compile hello C with strict warnings and output a binary called hello. So this hello C being the source, and then this is the output. Insight. This is the linter. Okay, yep. Got that. Thank you. And there it is. This hello is, it has no file extension. All right. /hello Alice Bob. Hello world, please subscribe. You passed 2 arguments. Argument 1, Alice. Argument 2, Bob. Success. Thank you. I noticed that hello has no file extension. How does my computer know how to run it? Doesn't need one. File extensions are just conventions for humans. When you run hello, the OS looks at the first bytes of the file, called the magic bytes, or file header. With Mac OS, compiled binaries are in Mac O format. I have no idea what that means. And the OS recognizes that format and knows to load it directly into memory and execute it. Okay, so there's something at the start that's like, this is a program, it's a compiled binary, loaded into memory. Interesting. I guess that makes sense. You could name it Hello Banana, it would work. This is different from WebDev where the extension matters. Yes, that's why I was confused about it. It's raw machine code. Okay, file hello. Mark O, 64-bit executable ARM64. Interesting. Interesting. Okay, so by machine code, do you mean binary or assembly? So hello.c goes into assembly and into machine code binary. Oh my gosh, GCC does both steps for you in one command, but you can actually see the assembly in between if you're curious. GCC -s hello.c, and that will present hello.s, which is assembly code. Makes zero sense to me. I'm guessing these are pointers to memory. That's crazy, dude. Wow. This is actually my program, my C program in assembly. Sick. And these are like move. I know this from the game TIS 100. Move W0 to whatever. add, I don't know what LDP is, but that's pretty cool. That's pretty cool. These are like literally instructions to tell it to move and add random stuff, copy stuff. I don't know what it is. That's amazing. That's why I see. So when you run hello, the CPU is reading raw bytes and executing them directly. No interpreter, no VM, no runtime. That's why C is fast. Get you. Thank you. That's pretty cool. All right, what are my notes? Notes is we've skipped. Okay, so session 1. Hello world. We have skipped. What is the pointer there? Split this panel here. Notes. So you hashtag include header files. Which have the function signatures, but not the actual functions. The actual functions live in libraries. The only library we've used so far is libc, which is linked. That's a concept. Linked after compile. Wait, is it linked after compile or at compile? Linked. The only library is libc. It stitches your compiled code together. I'm guessing it's after compile. Doesn't really matter. Okay. The other stuff is just syntax stuff, which, okay. But it seems to take argc and argv natively. VO native. Subs, yeah, this %d, %s placeholders are filled in by the next arguments. I don't know if that wording makes a lot of sense, but that's how I see it in my mind. Okay, and then we found out that like GCC compiles the C code into assembly and then binary. When the OS runs the binary, it reads the header, which tells it what it is. Okay, have I missed anything else? That's cool. I'm so excited. Like, I've written my first C program ever. That's pretty cool. I'm just going to commit this. Git add a, git commit. Yay! First program done. Awesome. Well, thanks for watching, and next time we'll build on this foundation.